A salesman records for each working day how much petrol his car uses and how far he travels. The table shows the figures for 10 days. Plot a scatter graph and describe any connection or trend that is present. So the first point is at 24,200. So 24,200 would be just there. And the next one is at 13,150. Now I'm just going to pause while I plot the remaining points. So I have all of the points plotted. And then we're asked to draw a regression line using our calculator. So what I'm going to do, let's bring the data back into view here. And then I need my calculator. So I'm going to go to statistics. I'm going to clear anything that's there. And then in list 1, I'm going to put the petrol used. So that's because that is on my x-axis. So 24, 13, 29, and I'm just going to pause again because you don't need me to see me do all this. So you can see that I have all of the petrol used in list 1 and all of the distances in list 2. I'm then going to go here, Calc, Regression, and Linear Regression. My x's were in list 1 and my y's in list 2. You can always change that if they're not. And then we're just going to click OK. You can see on the screen here it says y equals ax plus b, and below it gives us the values of a and b. So it's giving me 8.637 for a, and the b is 20.932. You'll see it also gives an r value, 0.957. That's an indication of the strength of the correlation. Anything above 0.8 really is a strong correlation. If I press OK, it gives me the scatter graph with the line of best fit drawn on it. We want to add that line to this graph. Now, clearly we can see from here that the y-intercept is at about 21. So, about there. Now, if I put x equal to 40 and calculate this, let's see what happens. So I'll have 8.637 times 40, add 20.932. That gives me 366. So that would be about here on our graph. And that means that I can draw that line through here. Now, more than that, if we go back to the class pad, I'm just going to go in here and resize. If I go to two variable stats, it gives me that x bar is, so we're looking for our point x bar, y bar here. So x bar is 24.9, and if I go down a bit further, y bar is 236. Let's see what happens when we put that on there. So 24.9 and 236. It's about there. So our line of best fit does go through the mean point. Finally, we want to estimate using the graph how far we could travel on 30 litres of petrol. So what we're going to do is go to 30 we'll measure upwards and then across, and it looks like 280 kilometers. One further note with this is that we would actually expect a line of best fit here to go through 0, 0. Think about what we're saying with this intercept is that we've travelled 21 kilometers on 0 fuel. But at the end of the day, we only have 10 points. And they're not perfectly lined up for things like traffic conditions and so on. So you just have to go with the calculated line, even when the intercept doesn't make sense. The other thing to be aware of is that anything below 10 here, so all of this part, is unreliable anyway because it's outside the scope of our data. We only have data covering us from 10 through to 40. So anything outside of that is unreliable, because if we look at the outside of the data and we try to make measurements there, we're doing something called extrapolation. Extrapolation is unreliable. You can only really take measurements inside the data, and that is called interpolation. And interpolation is fine provided we have a strong correlation, as we did here.